All right, we should be online, right? Firstly, I want to apologize for the late start. So it was the presentation was a bit delayed due to uh, technical reasons. But all right. So I'm here today to give you a talk about API first. All right, great. What is API first? Why it is used, and how it compares to other approaches to building API? Why does it relate to microservices, and how can it help us actually build beta APIs? Let's get started. So first, a few words about me. So I'm not like a rock star or something. So I've started. So this picture is I'm quite young on this picture, but it is quite nice. So I like myself. All right. So I started programming very in the old age of computers, where actually Apple II was big thing. I got very passionate about programming and actually didn't look back, I think. So I spent few years, so my junior years were actually doing competitive programming using Pascal and C, doing some national competitions. And then I got like out and go to the university and started working. I've worked almost 19 years at SAP on mostly Java technologies, various Java-based products of SAP, and different platform features of SAP products. But mostly I was kind of on this lower level where I was working on actual implementations of web services or web services stacks and XML serialization, deserialization. This is now kind of obsolete. But next I moved to the various other products of SAP. So I joined July 2019 as a solution architect in Paysafe, and since then I'm kind of focused on mostly business software, I would say, developing business software and features. My interests include pragmatic and agile architecture, of course, development productivity. So I kind of figure out that for implementing complex architecture solutions, sometimes the productivity or the gap between the architect and the developers is too big. So there are hurdles of actually achieving the goals of architecture. You cannot actually implement that. And also I'm a big fan of clean code and clean architecture. And of course, like most of the techie guys, I like to kind of fiddle with tech gadgets. But enough about me. Why we're going to talk about APIs. So APIs are everywhere. I would say right now the world is digitalized and devices and different applications communicate through APIs. I mean, without APIs, actually, I would say the whole world is right now running on APIs. And then I'm showing this slide. So why I'm showing this slide, it is actually in the past, usually APIs, at least remote APIs, were mostly referred as external communication for the software systems. So they're like mostly used for transferring data between different systems. Right now, APIs are kind of exploding, not only external communication, but also internal architecture of the applications, which are built on microservices, which both internally and externally communicate through mostly RESTful APIs. So REST is kind of right now de facto the standard for remote communication. There are, I guess, other standards, but this is kind of the most prominent way of doing remote communication. So in this presentation, I would be discussing RESTful API. So I will not talk about SOAP or some other standards. Although they are kind of exotic, most of the principles apply that discussed here apply for these also other cases because of the following fact that actually most of remote APIs have certain qualities so which are make it quite different than actually doing local calls. So actually when we think about remote APIs, we should always remember certain constraints that apply to such remote APIs. So I've been actually participating in standardization efforts or so in the past where main goal was kind of to make the network layer transparent to the API caller. However, it doesn't, constraints always apply. I mean, you cannot actually run away from the constraints. I would say you must embrace it. But you should be very aware of these constraints because they're highly impacting the design of the APIs you do. So first of all, the coupling. Remote APIs are loosely coupled with the consumers, which means the implementation can be actually replaced, which is good thing, but also they can be versioned and have their own lifecycle management. But you cannot be statically coupled to these APIs, which means you cannot guarantee on the other side of the wire there will be someone actually thinking that the things you sent are the things that he expects. The latency is totally incomparable to local APIs, and the bandwidth, it's always constrained. I mean, regardless what optics do we build on, since the remote APIs, depending on how you're close or far away, the latencies and overhead, there is a much higher overhead. The bandwidth is limited. Also, very important thing that is often kind of, I would say, downplayed. It is so the data is converted. It is actually transformed in different ways. I mean, sometimes even kind of invisible to developers, but the data integrity is somewhat compromised during the transfer, which means various encodings are applied, and you should be very aware what conversions are made on the wire. Reliability is also a big factor. You should be expecting that the remote service is down. And you should have some contingency plan or at least monitoring to figure out what to do. Of course, independent deployment is very nice and scalability. So when you have remote communication between client and server, they can actually be, besides independently deployed, they can be independently scaled. And on the last place here, it is security. So this is very important, and actually it's worth a dedicated topic on the security. So security is not simple, but it is important. So it's not a good combination, to be fair. So it's important, but it's complex. But in this presentation, I will not be focusing on security because it's something that you should be aware. It should be designed into the APIs to be very well treated. But in this presentation, it's simply there is no time for that. All right. How the poor design of the APIs affects these qualities? I would say that when we talk about nice design of local APIs or some, let's say, library, there is a less constraint to get there's constraint to think about. So besides nice design or let's say nice documentation of such APIs, you could actually, by making poor API design decisions, you could introduce or amplify some of the constraints of doing remote calls. Such examples are ineffective communication patterns or ineffective data structures. Also, reliability could be compromised if you're doing constantly incompatible changes or you don't have very clear contract on the data structures you use. So basically, as I mentioned, poor APIs, besides really hard to maintain, they have they contribute to very high operation cost and a lot of issues in the software systems. I would say doing poor vocal code it may be of less significant than designing a poor API, remote API. But what are the qualities of good RESTful API? First of all, considering you have a lot of constraints, usually the good RESTful APIs are use case centric. So they're not like generic to do everything. Their main purpose is to fulfill the use cases they are made for. Which means every overhead on top is something like a hassle. Also, they're intuitive, of course, clear, consistent. That is like a quality of each API that you make. But one important thing that should be mentioned is stability. So unstable, which means APIs that change often are very hard to maintain because you don't have tight coupling to your consumers. And they should be also self-contained, which means most of the data needed or should be able to be obtained from the same API. Well documented naturally, because your stakeholders need to be aware of any changes are kind of present or done, or any specifics to the API. They should be able to handle this and adopt these changes. How do we achieve that? So almost like a requirement is to have some formally defined API specification. Right now, for RESTful APIs, OpenAPI version 3 is de facto a standard. It is based on OpenAPI 2.0, but enhanced a bit. There are other alternatives like OData, also Ramola for describing formal APIs. Even there are some proprietary formats. This is not the main point. The point is the formal specifications give you a very good baseline to not have ambiguities in your APIs, which means interpretations. So, for example, during like 5 or 10 years ago, even now, there is a lot of APIs explained on some wiki or some web page that you have to figure out by reading actually what is the message format you need to send, and actually code these APIs by doing trial and error. About the REST best practices, so these are like guidelines. They are very huge amount of this around the web. You can find it about how to best implement or mitigate certain issues or certain challenges the best way possible in order to achieve good API design. So I would say good amount of these practices are actually ways to mitigate the challenges of doing remote communication and actually don't get stuck in some performance or, let's say, reliability issue when you do design your APIs, or just conceptual inconsistencies. But I would say the materials out there, just leverage them. All right. But something that was not mentioned is, does the way we build APIs or implement APIs have an impact on their qualities? Is there a certain way to do it? To do better APIs or design better APIs, or it doesn't matter. So I've just picked most prominent way, or at least most widely adopted way to build or implement APIs right now, at least in the Java world, but I guess in also using other frameworks. It is code first. You have a requirement and you kind of vaguely translate these requirements into some API notion, but basically you get down to business and start coding, and just use some annotations in your code on your interface to kind of define or shape your API according to the implementation, so you can expose the REST API as early and as possible. So it's very intuitive to the way we try to do Agile. So we try to deliver something as fast as possible. And since I've already mentioned, we need to use a formal specification. There are convenient frameworks that basically build and generate Swagger 2.0 or Swagger 3.0 documents for us out of our annotated Java classes. So we're done, right? We are following API first. Not quite, I would say. first of all, let's see what are the implications of actually coding first things. So I would say, again, I also mentioned that it is preferred for speed of delivery. I mean, you get your API, I mean, in just a few minutes, right? There are such examples like how to do REST APIs with Spring, right? You can do it in 10 minutes, right? However, you should be very much aware that the APIs are byproduct of implementation, which means the specification you give to your custom or to your stakeholders or your API consumers is basically inferred from the implementation, which actually means that you're kind of don't have any contract with them, so they don't know what to expect, right? So, which means if you don't have implementation, then mostly you cannot get feedback, right? So what are the pain points here? So my main concern with this approach is that actually you are providing implementation generate API out of generated artifact. So you have an implementation and your specification is actually generated, which basically leads to the following common mistake is that developers of such APIs are actually exposing their internal data model. And then it's very hard for them to change this without affecting their clients. I mean, for them, their internal data model is actual API of the service. And this is very problematic long-term. So short-term, you have fast delivery, but long-term, it's very hard to refactor such services. Also, mostly if such approach is taken, there is no kind of very detailed contract. So basically, it is often that contract is generated out of coincidence, which means, for example, I would tell you one story. It was not so long ago that I was in a meeting, very interesting meeting, that developers have implemented a service using code first. And in this service, there was widespread usage of Java util date. And they were enthusiastic to replace it with this new fancy Java 8 date times finally, so get away with this very cautious handling of timestamps in the software. But what happens is they broke their contract. And the first thing they figured, they don't actually know what the contract is, because the structures that were serialized or exposed to their consumers were inferred from the implementation and were actually not compliant with the schema exposed. So, and it's just an example how actually going code first is having big implications for the project at later stages. So what we can do about it is, why don't we develop the API contract first? I mean, at least design it, and then based on the feedback, and we can start doing implementation, right? So this actual number of steps is taken from Swagger.io. So it's a blog there for how to turn into API first. So API first is something you cannot do, like you can try to do it locally, fine, but it will be challenging. So usually it's taken up by the whole organization. I mean, to actually revert the way the APIs are built in it. So because the whole structure of the APIs is very dependent. I mean, there are certain qualities that we want to achieve in the APIs to be self-contained. And to achieve that, you need to separate APIs in groups, or at least in domain, in groups that are self-contained. And in order to figure this out, you need to brainstorm what APIs needs to be built for certain use cases. This is kind of similar to when you start to design a microservices-based system, where you have to figure out which data belongs to which microservice, which is very important, since in distributed system, you need to know who is the owner of the data, who is the master data owner, and who can change the data. And where is the master data, I would say. The next thing, besides actually brainstorming and figuring out what your APIs do you need, and I mean, is actually who needs them. Stakeholders, I mean, if you go for API first, you would need stakeholders to validate these APIs. If you don't have stakeholders, you may as well go to code first approach. Since you build API contract for someone, right? And this API contract needs feedback. I mean, it's not like you just build it and no one is giving you feedback. You will be just, as I said, use code first. So designing the contract is usually done using some formal definition language, which means you don't generate the Swagger or the API spec out of the Java classes or your language specific artifacts. You actually start writing Swagger, right? And this Swagger is describing what methods do you have, what structures do you pass, and I mean how this API should be used. And you use this as a contract to get feedback from stakeholders. For this to work on grand scale, you should create a style guide. I mean, there are still interpretations how certain problems are supposed to be solved. And as we mentioned, good APIs are intuitive and consistent. And to be consistent, you need a style guide. However, to figure out if people are actually using this or following this style guides, you need some governance. So it looks scary, but it is not. I mean, you can simply implement governance by doing peer reviews and collecting stakeholder feedbacks and simply static linting. I mean, it's pretty trivial. So it's not that every API needs to be approved by the grand architect of the company, but basically it's a way to figure out if you're actually doing things right. Automation is, considering that we are using a lot more tools than code first approach, is paramount to adopt API first. People should not actually build manually clients or do manually annotations. It should kind of alleviate of the people developing or consuming APIs of some effort, so to compensate for the additional effort of doing the API design. Tracking and managing APIs is basically figuring out if you have, when there are a lot of APIs, you have to kind of at some point check out if they are consistently defined or there are some other like duplications or irregularities in these APIs. But this is when you have a lot of APIs, right? And it's kind of just cleaning up the API portfolio to figure out if you have some issues. Of course, in order to be able to do APIs, first you need some API portal. This is actually where your stakeholders and developers can collaborate and figure out what API, what are the changes that need to be applied to these APIs. So this looks kind of very neat, processes and so on. What are the benefits? I mean, because this thing in the start looks very complicated, right? It's so enterprise, right? So first thing is feedback. I mean, as mentioned, the whole point is actually doing the right things, not doing it very, very fast, and doing it correctly. So it would reduce rework in the later stages of the project. And why would we reduce rework? Because it would not or less likely to introduce you to incompatible requirements. So these developers can work in parallel because they can mock the APIs once they have the definition of the APIs even before the implementation. And ensuring good development experiences for others is just having nice APIs. For consumers, for developers is just caring less about the tiny, if the contract is well defined between your clients and your implementation. And last point is something that I guess not everyone would agree, is that it should tend to reduce the use of middleware and reduce complexity. So once you build very fast, very low quality APIs, what happens next is that it's not that the APIs get re-implemented, you put a middleware in between to kind of make these APIs look nice. So I've worked quite a long time in the enterprise business, and I would say this is one of the more complex software systems to maintain and to support and to develop for. So this is thing that personally, I would use less and less if possible. And mostly for exposing our data from legacy systems, or in very specific scenarios where actually there is a benefit. But in general, I would not really rush into building new APIs that are not nice, and then try to mitigate this with middleware. Because basically one thing you should consider is middleware can break, and it breaks. It's like additional software systems in between. So challenges for adopting API first is actually, first developers need to kind of learn the stack. So it's not something, at least in my opinion, that is just architects do API first, and developers just implement, and that's it. From my point of view, developers should also define APIs. So the role of architect, in my opinion, is just giving feedback, just helping defining the best APIs, but this should be practiced by all developers in the company. So they need to learn the tooling for this. What you can do is actually try to make tools accessible. So no tooling access or no integrated environment where people can practice definition of APIs, generating their clients, no automation. It's really, really a blocker for actually doing API first. If developers are not really sold the idea of doing API first and convinced that it solves a problem for them, it's very hard to implement. And I would just leave the 2 points here that are important, that are not so technical, but very prominent is when you do an API or implement a service, first you need at least some stakeholders lined up. As mentioned, if you don't have stakeholders, this makes it very hard to collect feedback. I mean, you're building API definition for no one, and this is something. Sometimes it may kind of slow down your progress to make. So in some cases, you have stakeholders, but they are not available right now. So make sure you make them available so they're involved in the definition of the API, because otherwise there is no point. And the next thing is kind of some pressure from agilists, or guys that just want to deliver something and then fix it. I mean, so this is valid concern, but you should be aware you may be compromising some things in the future. So this is pretty common. As I said, one of the main use cases, or let's say benefits of doing code first, is you deliver something very fast. It may not be the best, but it is something. All right. So how can we help developers to actually do API first? So we gave at least a lot of thought about it. And one approach is actually to make it developer-centric. So most of the tools, at least if you look at it, and the solutions and the hype around the web, it is kind of management, product, and architect-centric, which means that there's just shown a number of people just doing the API development, and the other people are just doing API implementation. So it is something that we look at it and we say, okay, but it should be the people that implement the APIs actually working with these APIs definitions, and they should be in close connection. If someone want to give feedback, it can, but the environment should be kind of very familiar to developers. So one solution for this is that API definitions are stored in Git, and all changes are tracked. All changes can be reviewed, and actually you can very closely relate the API specification to the implementation. So I will mention later how do we achieve that, but there are specific tools already for that. So it's not something that, it is unconventional. So allow design tools usage, or at least design tool usage of various tools. You can use web, you can use Swagger editor, you can use desktop. It's up to you. As soon as the tool is based on Open API, it should work. But since the data is stored in Git, the results are the same. So that's like preaching that some tool is better. It's up to you. But all things end up in a common portal. So people can see the results, but how do you kind of change the APIs? It's up to you. I mean, so whoever, whatever tool is convenient to you. And the next thing is important, since, I mean, hand it over to APIs, to wikis, to some content management systems or something else. API lifecycle is integrated into the release process, into development process. So for example, if you kind of do an API change, you make a change list or make a pull request, you do changes. This is get associated for implementation, and it gets reviewed and released. So these lifecycle changes of APIs are pretty much changes part of the. So API has its own lifecycle, but it's quite integrated into the development process. So it doesn't have to be something separate. And then provide the tools to developers to actually leverage these API definitions, so they're not kind of they have some benefit for speed of delivery for actually having these definitions, and have to worry less about underlying layers. So one example is server-side and client generation. Very easy to. It should be very easy for them to consume services, to figure out what the API service exposes, how to generate a client. All right, let's see how we're with time. We don't have much time. All right. So how did we achieve that? So first thing to mention, it looks complex, but it's not really. And the next thing I want to mention is that this design can be actually implemented with different tools. Inside Paysafe, we have right now this supported with totally different stack. I mean, the only thing the same is, I would say, Open API Generator and Stoplight. So in the middle, our API design management system and software and API portal is Stoplight. So it has a free tier, so it's available also for on-premise deployment. It's something that could be replaced with Swagger Hub, for example. It depends on you. For us, it gives the following capabilities. So first main feature that we leverage is that it can actually edit and manage APIs that are stored in Git. So let me just start drawing. Actually, Stoplight doesn't have its own complete lifecycle management system or some storage. It's basically connecting and managing and editing APIs that are stored in Git projects, which means all changes on APIs are tracked, very accessible to developers, so developers can make changes either through Git directly with their IDE, for example, or propose changes through a pull request. And once the changes are made, they can do the following. They can generate service stubs and start implementing, but at the same time, once they do a pull request and they propose changes on the API, as part of the release process or the build process of the change, the new APIs are published. So what's the difference? So the difference is that the people editing the APIs are totally different than the people consuming APIs. I mean, usually. So basically, once you make a change or propose a change in a pull request, the API changes are published, and you can see what is the change. So stakeholders can actually evaluate and give feedback before the change is released, and the new service implementation is deployed. For actually generating the stuff, we're using this Open API Generator. So this is an open source tool, which actually I think have generators for pretty much everything. Inside Paysafe, we have customized it a bit with our own templates, but it is the open source software we use. So what happens is that, for example, I propose a change, I make the change. I can use either Stoplight Studio, either locally, or I can use whatever editor I want. And once I make the change to the API and create a branch and start, I can, in parallel to starting implementation, I can share the design with my stakeholders, and this is done automatically through the build process. Once everything is fine, I have implemented my API, I can release it. So releasing meaning, so what the release of API means. So actually release is not just say this API is final and no service actually implements it. Release is actually having the API and the service actually that is implementing the API already implemented, right? So we store the artifacts in Maven repository, which later gets deployed. You can deploy it anywhere. It is also, there is a Docker image, of course, but this is really a detail that I will show. Basically, the implementation is there, right? So you cannot see an API is released if there is no implementation to use. I mean, for service discovery, you can use whatever means available. It is not the goal of this presentation. But basically, once you kind of have a release, we store this released artifact. So basically, anyone that want to actually consume the API can figure out what is the service that is implementing this API. And make sure that there is a close match between the service. You can actually figure out what version of the API this service implements. So you can generate a client, of course. By references, there are artifacts. We have created a convenient Gradle plugins or Gradle dependencies for this, but it's pretty common. And this way, the API stakeholders can actually know whether certain change is released or where it's actually, what is actually the state, which supports very well the agile development and clean development process, which means even if you support API first, you're not required to release everything at the same time. I mean, you can gradually update the APIs and get feedback and then update the APIs. And your stakeholders are kind of in the loop of these changes. They can track it, they can reverse, for example, or demand changes. All this is managed through a GitLab. So there is certain benefit of GitLab having all things in the same place, at least for ease of understanding how things are working. So previously or right now, I mean, we have different tools in our company. We're having this combination of Bamboo, Bitbucket, and JFrog Artifactory. And although we have implemented the same process there, which is basically exactly the same, it's very hard to track the lifecycle of these artifacts because of the different tooling that is used. So it's time for demo. And let me see. So I have just very little time for demo, right? So what I have built is one service, calculator service. It's not the point to kind of make some complex APIs and show you how the publication of the APIs and editing of APIs is streamlined. So let's get down actually to, let me find service and how the service is concerned. So we have this microservice that exposes some API. So actually to figure out what API this service exposes, we have to go to our API portal. So API portal is also not only portal for the APIs, but it's also portal for documentation. And in this portal, we have pinned, so this page is kind of the homepage of the portal. We have pinned very important tools for actually doing API first. So one is the generator, where you can use this generator to generate server-side stubs and client-side artifacts. And the other is the stoplight plugin. This is a Gradle plugin that is integrated in the build, which actually does the following. It gives you Gradle tasks that publish the API during build. So this is kind of template, so it's not very complex for developers to actually reach the information they need, and the tools are available. And then here is the documentation how to actually use these plugins, but I would say developers just take here if they want to just generate a stub, they just take an example, adapt it, and that's it. The important thing is how do you find APIs? So here there is this Explorer tool, which basically allows you, this is the API portal where it allows you to find actual APIs. And here I would say that basically, let's see the calculator service. Here you can see that it has these APIs. And actually it has just a master branch, which has its initial version. And you figure out that this is the service provided by this microservice. So this is the group ID, and since we use Spring for implementing microservice, this is the group ID and artifact ID of this microservice. that is implementing this API. And also this is versioned. So if you go to the docs, you can actually see what this microservice provides. So it is a simple service that just calculates numbers. It has this is the data model of the service. This is the calculation structure. You can figure out that it has two operations for addition and subtraction, and it has one enumeration for these operations. So what you can do from here is, as a stakeholders, you can either download or you can access the mock URL, which is even before the service is deployed, you can actually test it. And here is examples request and example responses that you can use to test it. So mock URL is available. And here you can try it even against mock server. So if you click enable mocking, you can play around by testing the service. You can have either static or dynamic. The point here that I wanted to demonstrate is that before implementing the service, actually you can get feedback from your stakeholders. How this is implemented in the build, and first, where is the API definition? So where is this magic happening? So actually, it's exactly here. So this is the YAML. So this is the Open API specification that describes this service, and it is inside the code of the service. But is there a more convenient way to do it? So one way to do it is just copy this and use some editor, right? So you start editing the service. But there is really better way to do it, and it is to open it in Stoplight Studio. So this is a web-based tool. Anyone can access it if he needs a small changes, or there is a desktop version where you just locally open the file and edit it. I will just close to see. I will just open. I have opened the project, but basically you just paste the Git URL, and it will figure out the project. Here I will demonstrate one streamlined change. So I'm looking here. This is the project, and if you see here, I'll just switch to master. It's integrated with Git. So I'll pull for the latest changes from Git. All right, so we have some questions. I'm just wondering whether we'll have enough time. So probably I just...
You have enough time.
All right. I'll just do a simple change just to demonstrate how the process is streamlined, and I'll show the pipeline so you get some idea how this is working. So I have an API, right? But I want to do some changes to it. So right now, what I see is that it can do just... so you can either edit the YAML files or you can edit the through the visual editor. And here I see that I have two operations allowed to this API. I have addition and subtraction. And I want to enhance this API. I mean, I have a requirement by stakeholders to enhance it a bit. So since I want to demonstrate the workflow, I don't want to demonstrate very advanced API capabilities. I will just say here and okay, I suggest here to add multiply operation. Let me see, multiply. And just start it, right? So I did make a change to my API. Here the button for commit shows, and now I will need to just create a branch for it. So add multiply operation. You see, I didn't code anything, right? So I create such a branch. I didn't like my name of the branch. All right. Okay, I'll be better. All right. I didn't create it. Come on. All right, so I can create this branch. I can do this also from local environment. I can commit this. So, all right. I will just push this. All right, so I've proposed a change to my API. Now what happens is that first I need to show you at least all right. Let's first show you how this thing get published. So I've shown you some nice site about this documentation generated for this, but the question here is how this is generated. So whether the developer had to do something or how is actually it was done. If we look at the release pipeline, so we have build and we have release, and once you release, we have different steps. One of the steps is publish API. So this step, actually what it does, it just takes the master branch, runs a command line tool that publishes the master branch to stoplight. All right. So this means that every time a new version is released, along with the service, we have the corresponding API published, and people can figure out that this is the actual API supported by this service. What happens with changes? It is pretty obvious that we would want also to see what are the proposed changes in the APIs. So actually to do that is that we use merge requests, and the pipelines for merge requests are publishing a dedicated API path, let's page for these merge requests, so you can figure out what is coming. So actually we create a merge request here, add multiply operation and submit this. So once we do this, a pipeline would be triggered, and I will just show you the pipeline. I don't know how much time it would take, but it would publish the branch, the API branch, which means it will show the changes to stakeholders. All right, so how does I approach the implementation? So first I would need to check out this branch, right, that made the changes. So let me go to my IDE. So I will just go to the calculator service. I hope you see my IDE. I will probably just disable streaming. So is it better now? I have here my service implementation, and you should note something. So my server-side artifacts are generated. I mean, all this, it's not even committed in Git. So which means that upon build, I would be generating my artifacts, and my only thing that I have is which is using this POJUS, right? So how do I achieve that? Is very easy. I'm using in my build. First, I've added these generated artifacts in my source tree. Then I'm using these plugins. So one is the Open API generator. So don't be scared. This is just a thin layer wrapper of tasks for convenience. This is the Open API generator that I've mentioned. This is the open source project. But basically, we just created these custom tasks, generate service code, and generate client similarly. And this one is taking the API definition here and generate our artifacts. So actually, why do we generated our own plugin? It is because the number of options of Open API generator is kind of daunting. So in order to kind of ease up the developers to generate kind of the same things and make things kind of more the same across projects, we just generated wrappers and our custom templates, so developers can at least have some easy time passing parameters. So these snippets are provided in the homepage of the generator, so they can just copy paste it and just change some parameters. So there is nothing interesting here. We delete the generated sources, upload clean, and we generate the new code. So the point here is what I need to do as an implementator. I'll just let me pull. And I'll just need to see the new remote repo. Add multiply application. So I will checking this out. And I will need to do just a build, right? So once I do a rebuild, is the only thing that I will need. It will just automatically generate the new things needed for my implementation. So I'll just do a Gradle clean build. And the new property in the operations would show up, so I can go about and implement my service. So since we don't have much time, I will just move to the consumer side of things. Let me find how do you consume service. First, let's see what's up with the pipeline. All right, so it crashed. So what's up? Right. I messed up something. Let me just try to increase the version. I need probably to do this. Some dependencies is missing. So I think there is some issue in the connectivity of the machine or something. So there is some issues in, so dependency cannot be fetched for some reason. All right, so the interesting thing is what happens upon build. Let's see the pipeline. So what actually is release? So let's say we have a build, and so now it's, let's see if it's yes. All right. So how do you figure out what is the version of API? So in packages of the repository, you see here a released version of this service. So actually here, these are the artifacts of the service. So upon release, you see this zip file here. So we created a Maven publication for the APIs. So actually, you can actually, you are attaching the API definition as a dedicated artifact. So this is actual version 1.1 implemented. So besides publishing into, hopefully, publishing to Stoplight, you would be also having these artifacts. Actually, you can reference these artifacts by your consumers. So let me see how I can consume a service. So I have created a project. Again, we did a little bit of trick here to open API generator. And this trick is pretty easy to figure out. So let me show you the calculator and overview. You see here, there was in the definition, there is, here you see it here, these tags. So during publication, we replace these tags with concrete service reference, which basically allows us when we consume the service just to take this reference. So I'm stakeholder, I'm just copying this. I'm going to my consumer and I'm defining the following. I'm defining this API contract dependency and pasting this reference here. So this actually would do, it will take from Maven the concrete API definition that is coupled with this service implementation. So how does it help me? It helps me because when I want to migrate to new API version, I would know what would be implications for me. So it is implicit change. If there is a support of versioning to the microservice, I can also align my endpoints, but this is intentional. Even I can generate two clients based on different API versions. So here the pattern is exactly the same. We would have a generate client task, which would be just passing the parameters down the stack. And how this definition is taken from the Maven repository, it's just like any other dependency. So it's just zip file, right? So it's pretty trivial way, or I would say very obvious way to actually resolve reference to API implementations. Why we wouldn't want to do this reference to the live server? It is very obvious that this can be changed by someone else, and it may be inconsistent with the implementation. So let me see the pipeline if it succeeded. So I wanted to actually demonstrate that it's still running. It's very slow. All right. So I will demonstrate to some other on some other branch, so on some other projects, so we have some time for questions. So I will just go to the Explorer and show you how it looks like from other services. So let's go to this service. You see here you have master and test. So this is some test branch that I have created. So if you go to the APIs and you go to the documentation, actually you can overview and give this to your stakeholders so they can check what changes are there. And also in the editor view, you could actually review the changes here, right? So basically, this way, stakeholders can collaborate and track the implementation progress of the APIs. Also, it allows very, very close collaboration, and it doesn't actually prevent developers, or at least decrease developers' productivity. Let me just see that. So it may take a long time. I guess there's a lot of dependencies. So let me just go to the presentation. All right, so what tools are used? I would say pretty much standard tools. We have some continuous integration system, and here we use GitLab, but as I mentioned, we use other tools right now. So we are in process of migrating. Stoplight, we need API portal. Whether it is Stoplight or something else, it needs to be integrated with source control system. That is our boundary condition, so we can actually work or maintain the versioning of the API specification in the code. Open API generator and custom plugins. So you can use it out of the box, I would say. It works. The only challenge is it is not very intuitive. It has the not very intuitive Gradle plugin. At least the parameters are very, very weird. So to easify and kind of standardize things, you should probably do a wrapping or implement your own plugin. So let me see the questions. All right. So here the question is about RESTful and gRPC. So gRPC, as I kind of look it as a transport layer, a packaged, let's say, more efficient format. In its essentials, it is more or less a similar concept. Again, you need to define a type, a typing, or let's say to have strongly type interface definition for this. So it's not far and away to support this with the same approach. All right, let's see if you have some other questions. All right, so there is just one very long comment on solving the same problem. All right. All right. So there is not much questions in the chat. All right. And since we're kind of out of time, I really appreciate your attendance to the presentation. I hope you enjoyed it. I hope you learned something today, and you can actually take it even if you're not implementing API first directly. You can try to at least get involved into the idea and start promoting it in your organization. There is a lot of tools around, and it would probably take some kind of research for you to figure out how to approach this problem. For us, we hope it brings a better APIs and more stable APIs. And thank you very much, and enjoy your conference.